Hello everyone, my name is Cleber. I'm just going to show here the presentation Automated Deployment of SAP Applications use NFS share on Azure. On this presentation, you are going to show the motivations for this work, the challenges that you are facing doing this kind of work, the components that you have used in the architecture, the resources from Azure that you have used, a support based on Azure materials. We are going to show a demo about the full deployment of the SAP Enqueue replication server in high availability, and possible next steps and future topics that we could improve this work. This presentation is being conducted by me, Cleber Paiva de Souza, and my colleague Gabriel Cavalcante. Um, Motivation. First of all, this presentation is based on Microsoft Azure article available on this link. On this link, you find a set of procedures that must be followed to deploy SAP Enqueue replication server in high availability using Azure with Azure NFS shares. This is an implementation that is not officially supported yet, but is in review for publication in the next months. But we this work was done with a customer that is being supported by Microsoft Azure team. And Microsoft Azure team supports some customers to deploy and test and use this kind of deployment. We also understand that this kind of deployment is complex, is slow, because you have to configure many resources on Microsoft Azure related to high availability and also configuration of the components of SAP. The last motivation here is that we challenge ourselves about how could we do to make it as fast as possible, is most easy as possible for dummies. So people that sometimes have low or basic knowledge of SAP, it could be possible to deploy or make it easier for those people also to deploy complex infrastructure of SAP using high availability. So these were the motivations that we had, and we try to do our best to make it easier and as fast as possible for all kind of technical personnel and skills. Some of the challenges that you have faced. First of all, when we have discussed this scenario with the customer, they want to do is this as fast as possible. So the deployment that we presented here is about the deployment of SAP Enqueue replication server with high availability. But we also understand that all other components of SAP also must be deployed in high availability or some kind of load balancing. So you have tried this approach also for SAP HANA, also for Web Dispatcher, and for SAP SAQ application server that we show here. Um, uh, we also made a set of automations that could make do it easy for using existing resources that customers could have on Azure, or maybe creating from zero, from the ground, the resource, and make all the configuration that is needed for this kind of application to work in Azure. We made some we faced some challenges using internal network for the communication. So you created some approaches here, creating second load balancing, creating support for net gateway, and create something that could be easily reproducible and without or with basic SAP knowledge. So one of the challenges that we tried to do in this work was to make this deployment as easy as possible in a way that people with no or basic knowledge of SAP and high availability could make it working without many changes. First of all, we say here some points about the components that we have used in this work. We are using here the concept of infrastructure as a code. The idea here is to create some description files in a high level language that make easier the description of the components and configuration of the environment. We are using Terraforms and Salt in this work. Um, with Salt, we have the feature of avoid destruction in a way that only objects that are managed by Terraform are destroyed. So we have some safe measures in a way that something in production that could be managed or updated by Terraform is not updated wrongly. We make use of custom cloud init after the infrastructure is launched. We use cloud init features on Azure to make all the steps for turning and configuration of all the components inside the operating system. We use the feature of Salt using modular deployment, and we populate some files related to pillars configurations that was populated by the cloud init file, and we use the Salt formulas that is available on the SUSE for SAP, and we provide here the links from the SUSE GitHub where you have all the code from the Salt formulas. The architecture proposed for the SAP Enqueue replication server in high availability uh, requires the availability of NFS server using the version 4.1. We could do this manually, but we have automated all the process with Terraform so that the storage account could be created by Terraforms. All the shares and configurations needed for this storage account works with NFS 4.1 works was done. Um, and also the possibility of using an existing storage account with specific configuration was also tested and validated. We created the directory structures to keep all the information that's going to be used by the ISCS and ARS on the NFS share. Of course, you have some limitations that is related to the number of cluster that we can use in the same storage account. So in the Azure documentation, we can check uh, informations about the maximum allowed recommended number of cluster that could be used the same storage account to avoid performance problems. And we have also implemented the resources of private endpoints to guarantee that NFS traffic goes to a secure channel, and we have some safety measures to avoid that data could be um, viewed in any way in the network. One of the points that we had some warnings during the project was that when you use internal load balances, as instances are not able to route traffic to internet. So you have two alternatives for this approach. One of them implement a second load balancer called outbound load balancer for this traffic. And another way was implement an net gateway to route those traffics. We were using this traffic for things like updating and applying patches on the instances so that the launched instance are all using the last versions of the patches, and everything is saved in the operate systems. Um, uh, when when we discovered that we had those both options, we implemented both on our automation so that the customer could select which one is the best for their deployment. um, but when the load balancer or instance have some public IP, uh, there is no need for additional configurations, and these alternatives that we propose here is not needed. Um, and also we have mapping out the front-end IP configurations, probes, roles, loading balance roles dynamically in the Terraform so that any kind of mapping in the load balancer that could be needed for the customer could be updated in Terraform definition file. This is a list of the resources that we have supported in our work. We have supported here for using of network security groups. It's important to say that most of those resources are supported for existing resources and also for the creation of new resources. We have supported for multiple Azure storage. We've separated storage accounts for SAP Media, for SAP Data using NFS 4.1, SAP Trans Data Area, supporting NFS 4.1 or NFS 3. Uh, um, Storage accounts for specifics for the instances and also for boot diagnostics. So all those kind of storage accounts are supported in our deployment. We have implemented the support for private endpoint to secure and make our NFS communication private. We support availability sets and proximity placement groups so that we have the resources, the instance resources is split over multiple um, data centers or zones, but as close as possible. We have supported Azure fencing for high availability in SUSE for SAP. This work was extended from the last presentation we had showed at SUSECON, where we had suggested some patching for SUSE Azure fencing. This code is part of SUSE for SAP, high availability extension. And we also implemented the support for internal load balancer, outbound load balancer, dynamic creation of load balancer roles, the all pieces of information related to load balancer, the front-end IP, probe roles, load balancer roles, etc. Also, the support for net gateways, support for tagging, so that most of the components on Azure you can use tags for use for billing or grouping. Support for public and private address, for instance, and also for load balancing. Support for use of bring your own subscriptions so that customers that are using Azure with their own subscriptions can use those subscriptions on Azure. Um, and also the implementation of support of Microsoft Azure events on high availability. So, in case you have problems with the Azure data center, the cluster is going to be aware and take the actions before the problem in the infrastructure happens. Some information about the results that we have for the SAP Enqueue replication with high availability. We take some measures in time so that we can have estimated time. In these times could depends on the kind of structure, the architecture of the machines, um, connectivity, performance of the hardware, and but we have some estimates here about 3 minutes to deploy the infrastructure, three 3 minutes to make all the SUSE configurations and apply patches to the latest version. Configurations of SUSE availability stack installation and configuration takes about 2 minutes. Deployment using the salt formulas of the SAP, SAP, ASCS, and ARS Enqueue application server takes about 5 minutes, and sometimes this could take some more times, depends on some validations and checkings of the connectivity that is going on. Sometimes this time could be doubled. So in total, you have around uh, 13 minutes of total deployment with zero comments of execution on those systems to make the deployment working. In some scenarios, you could have something take some times around 20 minutes, but we understand that this kind of configuration, when doing manually, easily we can take around 40 hours of human work time, and we if we are going to reduce to 20 minutes is something impressive, even that we are considering that there is no need for running no commands after the deployment of the Terraform deployment. We made all the validation through the SUSE Hawk interface, and we simulated scenarios of failure using scenarios of immigration and also scenarios of crashing, and we validated all the stack by installing the SAP primary server application, point it to the load balancer IP address of the SAP Enqueue replication server. We also made some tests using web dispatcher with the same approach, but when we are using web dispatcher, we use load balancing to guarantee the high availability of the web dispatcher, and we take about 10 minutes to complete the deployment, and also without zero commands being running on those systems. Okay, all this code is published on our GitHub so that the community could check it, try it, make suggestions. You are free to hear from you. So if you have any comments, our work was based on Azure, but the idea also could be adapted for any other cloud provider or even for some scenarios of uh, um, on-premise infrastructure. But feel free to contact us. You have comments, you have opinions, you have scenarios like that you want help improving the performance. And in this demonstration, you are going to show the systems. So here you have the code that was running from Terraform. You have the information that was outputted here, referring to the environment. We have all the deployment here. Um, in the system, you have here um, the first node. We can check here with this graph in the log file that have created the time of start and time of finishing. So you have here around uh, uh, 20 minutes, but we have some scenarios here with other architectures that uh, we did this with 30 minutes. Um, we can check the configuration from the cluster stack, and also we could check this uh, in the web interface from Azure, where we can check all the components that was created, and we have here the Hawk interface with all the components created here. All the steps was created without any intervention, and when we can use the interface on Hawk to test or to migrate these resources, so we can test it to here. We are going to migrate the ISCS to the second node. So we could check here or here in interface all these migrations going on. So we can have here the components being stopped and the components being migrated on the uh, ARS node. Perfect. We are finished here. Done. You have tried here on process of migration. You have tried the operation of the cluster through the Hawk interface. You have moved the components from a node to another. Um, so the demonstrations show here that you have all the components working here, and the time that you expend during this process using our script. As next steps, we understand that we can put all those pieces together, and we can measure more complex scenarios, the time for those deployments. So one footer work that you are going to complete is use this automation to make all the stack with availability on Azure, since SAP HANA plus Enqueue Replication Server plus PaaS plus additional server plus Web Dispatcher through all of those components through Terraform automation, use the salt formulas from SUSE. And we want to test how fast we could do this. It make it easier as easier as possible for the community to consume. If you have more use cases, feel free to contact us. We understand that this work could be extended using ITSM tools so that we can leverage some workflow approval process that we have tests in SUSE Manager, but we understand that we could use these features also here to deploy those environment you integrated to business process that the customer is using. So that's it. We have our contacts in this presentation. Feel free to contact us if you have any comments, any suggestions, and thank you.